Hi, my name is John.
And my name is Alice. You're watching Math Videos for Parents. We help you so that you can help your kids with math. And today we're talking about finding sums with mental math. And John, I have to admit, when I was growing up, mental math wasn't something that was emphasized. In fact, we were encouraged to show our work. We needed to write everything down. That being said, I'm just going to plunge in and do this problem mentally. So what I would do, I would just look at the ones. I've got an 8 and a 0, so I'd put an 8 down. Now I'm looking at the 10s, so I've got a 2 and an 8. So that would be 10, and I've got to remember to carry the 1. Then I'm looking at 9 plus 4, which is 13, but I've got to remember to carry the 1, so that's 14. 4 plus 2, which is 6. Got to remember to carry the 1 again. 7. So I get 7,408. Now, that being said, I would prefer to write it out.
Yeah.
So I'm curious to see if there are approaches that make mental math easier.
Yeah, so what you just did was called the standard algorithm. Most of us have learned it that way, where we add things vertically, 8 with 0, 2 with 8, and when the sum becomes 10 or more, we carry over a 1 to signify that we're going to the next place value. But for students, they interpret that very literally, especially in the younger grades. They think carrying over a 1 means adding 1, when it actually means like adding a 10 or 100, depending on which spot you're in. So the methods I'm going to show help students understand place value a little bit more. Unfortunately, some of them are a little bit longer, but I think they give students a better understanding of place value. And the first strategy is called Make 10, and it relies on the associative property of addition, which means we can prioritize different sums first to get the overall sum. So to find this very same sum, we notice that, the second number is 480, right? So if I added a 520 to it, that would get me to 1,000. Like, that's a number I could think of really quick in my head that would get me to the next place. So the idea is, if I could take a 520 off of the 4928 like this, I'm just rewriting 4928 in a different way that's equivalent. But through the associative property of addition, I could reprioritize what it is that I want to add. So I can move the priority over to 520 plus 2480. If I add those together, I know in my head that that's 3,000. So if I add 4408 to 3,000, that gives me the exact same total as you got, 7,408.
I feel like there are some people where this approach comes quite naturally to them. They just take to it very readily. That being said, I feel like if it's not yet intuitive for someone, it is a skill they can get better at.
Yeah, it's just a way to kind of see numbers differently and regroup and break down numbers to make the adding more efficient. Now, if this isn't your cup of tea, because it isn't for a lot of people, we can also use something called the add-on method. And the add-on method is taking a number like 2,480 and breaking it up into smaller tasks that we add on to running total. So I can break this number up, again, going back to place value, I can break this number up into 80, 400, and 2,000. If I add these together, I get my second number. So the idea is I start with my original number, this 4928, and I add 80 to it, and I get 5,008. Then I add the next part of my second number to it. So I'm basically just taking the job of adding 2480 and breaking it up into 3 smaller tasks. I'm adding it up in parts or by place value. So now I can add 400 to 5,008, and that will give me 5,408. And then last, I can take that number and add the 2,000 to it as the last part of my place value breakdown, and that gives me 7,408.
Well, I like that approach. I think I prefer that one because it's very kind of linear.
Yeah, exactly. It takes a number and just breaks it up in a logical way that's dependent on place value. So I did the tens place here, the hundreds place here, and then the thousands place here. Now,
it's hard to believe it, but there's a third approach, right?
There's a third approach, and I think this is the most trickery, if you will, compensation. So the idea behind compensation is 4928 is an ugly number. So if I could bump it up to a nice number, like in my mind, this is really close to 5,000. I can get it to 5,000 by adding 72, which is all great. Like, I can add that in my head. That's easy. But I can't just randomly add 72 to a problem. So I then have to compensate by taking away 72 from the next number, so that overall my adding 72 and subtracting 72 becomes an even swap. And if I take away 72 from this group, I get out 2408. And now if I add them together, I get the same exact 7,408 that I got before as my final answer.
Wow. So many different ways to get the same answer.
Right. And the beauty is I didn't need a calculator, and I didn't have to worry about carrying ones over or anything like that. In my mind, I had to break numbers down according to place value or add convenient numbers to do it in my head, which are great skills for elementary students to have.
Right, great. I think of those three approaches, I think I like the add-on the best. So I'm eager to try a problem using that approach.
All right, let's do an add-on.
Okay, so I'm going to do 1,982 plus 3,415, and I'm going to choose to use the add-on approach. So first, I'm going to kind of break out this number, this 3,415, by place value. So first, I'm going to say, well, there's 5 ones, there's 10, there's 400, and again, I'm just breaking up this number here. And there's 3,000. So now I can just do a running total to add these all to my 1982. So 1,982 plus 5. It's going to give me that. And these are very easy to do in your head. Because we're only dealing with one place value at a time. Oh, John, I like this approach a lot. So I get 5,397.
Perfect. I'm going to have to borrow any ones.
I was just thinking that as I was doing it.
Or carry over.
Not a single one is getting borrowed. Or carried over, yeah.
And it's funny because you could do it the way you did it by breaking down 3415, or if I felt it was easier to break 1982 down, I could have broken that number down into 4 parts and then added that on to 3415 and gotten the same answer. And that's because of the commutative property.
Right. So yeah, that's a good point. So in fact, that might have been the better number to do because it's a smaller number. So interesting.
Yep. And that's the beauty of math. Either way we do it, it'll work out the same. There's always more than one way to get the answer.
This is what I love about math. One of the many things I love about math. Well, thank you everyone for watching. We're Math Videos for Parents. Please subscribe to our YouTube channel. It really helps other people find us. We also have a Facebook page, and don't hesitate to reach out if you have any math topics you would like us to cover. We look forward to hearing from you.
Thanks for watching.